all my variable and the data sets where it stays. It's not really so hard. Unlike other programming language, I can review them whenever I want. So it's also really great for me. Okay, I will go really quick through this one because at first I thought like we have some students, so we a little bit should be slow for them to follow, but we are the professor here, so I will go really
Give
so
us the
fast
hard
on that.
stuff.
I will just really go so fast on that. And also when I run for the R Studio, again the ggplot 2, that's one of the data visualization packet integrated in RStudio, work really well. And it provide me a lot of, I'm sorry, just running, but just take a few seconds to finish for the coding. It provide a lot of visualization effect for the student, for the client, for the user to easily imagine about the data sets. And by this way, when I conduct for my research, I can easily visualize rescaling for my data and create some very fancy graph like that. So this is the box plot. Normally, they also take more time to conduct and to run and create on other programs. But with this one, I guess I have it done for the coding. Yeah, it's just about a few seconds to create it and it still be rendering. But we can see the result right now. Here we are. You can see they're quite the same. My computer is just not so strong. Yeah, that is here. Yeah, you can see like that. I can simultaneously grab for 10 different plots in just one single graph. Very easy with very fast time. That's say a lot of time for me when do the analysis. And the same thing when we conduct for research, one of the things, like especially the economic guy really love you running for the correlation metric, which is really so hard to see right here. And if I try to just export them into an Excel file, they should be quite large. But again, okay, I can run them on RStudio for the visualization effect. I just don't know why it is so long, but yeah, you can see here.
It's not bad.
Yeah, we can make a really colorful and impressive visualization effect on that. I can a little bit change it and turn all the square to the circle. And the same way, so they also generate a correlation metric. Actually, like something like that is now is so preferred by the academic journal, but that's very useful for the, ordinary user, and they have a better understanding about the modeling. I'm sorry, I just don't know why my computer just working not so well today. All right, I will just skip it a little bit. So if I run it on R, the visualization of the correlation metric will be look like that. So I can turn them into the circle. Very easy to understand. This line is just for the cell correlation, so I just hide them. And for more advanced purpose, we can also use other library. Like right here, we have the ggli, and we can create a very fancy graph. A lot of information, the scatter plot, the correlation number. We also have the distribution. Just a little bit too overwhelming in data. But they really provide them something available online, and you can easily catch them and just get it. Uh, okay, so for the data mining methods I use for this modeling, so I use the classification model. And when I review for the previous empirical research, so I decided to use four different methods, including the logistic regression, decision tree, the artificial neural network, and the extreme gradient boosting. They can be ranged from a very traditional and easy to interpret model like the logistic regression until very advanced and recently established like the extreme gradient boosting. And we can see how they perform on. I guess like I would just show the result and the coding because it would take a lot of time for running the machine learning model. Normally, with the logistic and the decision tree, it takes just a few seconds, very quick. But for the artificial neural network or the boosting method, they require like half an hour on an ordinary computer like this. But anyway, with the machine learning process like that, it's to be very fast. It's really fast. So all the code shown here is something about the model building. So instead of using other library, I use the Carlo library. This is a machine learning library, and the way to retrieve the function is a little bit different. So for example, some people who have run the logistic regression on RStudio, for the default packet, they will be more familiar with the GLM function. But for this packet, they will use the train function, and we just have to specify for the syntax on that and can change the method we want to apply for the model. The same thing I apply and I generate for the result. I can see the coefficient, the G value, and the probability of the distribution. I can see which one is significantly positively related to the dependent variable and what is not. The same thing I apply for decision tree. I also build the model. I also summarize the model. And just like before, it's pretty hard for the ordinary state user to understand it. So I decided to run for the visualization effect to see how maybe the decision tree will look like. And I got something like this one. At least about the visualization effect, we can easily imagine about what will be the determinant of the decision tree, what will play more important role in the decision process, and the user, the client, can easily use them and adjust for the business model based on the model we created. The same thing with the neural network. They're quite complicated, hard to interpret. So I also visualize them and make a neural network map like this with the input variable, the hidden layer, and the output variable. So right here with the darker line, that means this kind of input variable play more important role and make a higher impact into the output variable. And we can see what would be the good predictor for the good or the bad payer when they apply for the low-end equity, low-end application. I also use the XGBoost, which get a very great advantage in the calculation thing. Like they can parallelly compute and make all the algorithm at the same time, so that can boost for the calculation timing up to 10 times faster than normal. And this is quite advanced and more recent method in data mining. The same thing happened. I applied the model, build it, and I got the model validation. You can see right here, that's going to be the accuracy rate. With this model, it's sometimes vary between like 21% to 91% up to like 94%. So that means this model can generate the accuracy up to 94K over 100K, the band when they try to assess and try to grant for the low-end application. That's a really high grade of accuracy compared to the traditional scorecast method before when all the traditional bank use, normally they vary between 60 to 70% accuracy. So that's great improvement, right? We turn into all the quantitative method. I also conduct some stay for the modeling, and I do the model benchmarking and comparison. So over here, I conduct for the confusion metric, what is very popular in the classification algorithm with the confusion metric function, and I generate for the confusion table. If they quite the same here, this is what we can receive and we can retrieve from the RStudio, and I try to integrate them into a table like this one. So over here, you can see all that. Also, the more advanced, more new established model, they make a higher accuracy, higher precision, and the record rate. So you see here, like for this time, I make it like 94% of accuracies for the model. The same thing. So when the client also really want to see the table, we can show them the visualization, compare between the different model and which one is perform best. So right here, all of the model and the graphs show that the XGBoost, the extreme gradient boosting, is really a very good method for the credit scoring and create a very high rate of accuracy. Here we have the Monte Carlo simulation. So for the specific business context of a bank, they're not required just a highly accurate model, but they want something can make that profit. So the question is, how can they apply into the real business context, and how can it directly related to the revenue and profit? So I try to run for a Monte Carlo simulation, and this time also the RStudio can show its power. I create some assumption and I run for the integration for the up to like 50,000 times for the simulation. The RStudio give me the chance to generate my own function, create an algorithm, and then run it over time again and again up to like 50,000 iteration, and generate for the distribution, the histogram of distribution. And I can see over here, like the same thing, the same result with the previous day. XGBoost also is a very good method that can generate for up to like more than $2,200 for its scale of assessment. But they also at the same time generate a very low rate of variation that represented with the only 11 in the standard deviation. So the model generates the highest profit, but with the lowest variation of risk. So yeah, I guess I will stop here because that I haven't talked about the main thing and my experience about when I apply for RStudio and the data mining method into my research and my project. And this really is very a great and beneficial experience for me when I can learn about all the kinds of fancy things of the data mining. And so thank you about it. Yeah, thank you.
Thank you.
Thank you very much.
Yeah.
Any additional questions we have?
So the Monte Carlo simulation was after your data mining, after you selected a data mining method.
Yeah, that's
right.
right.
Those are two separate
Actually,
steps.
they would take the result from the data mining result and then apply them for the function in the simulation, then run for and calculate for the profit they can create.
Right.
So
they're answering two separate questions, right? You're determining which data mining method should I use,
Yeah.
and then you select the best one, and then you put it into a Monte Carlo simulation.
No, at the same time, because at the first stage, I just generate the result and determine which model is most accurate. But for the second stage, I still run for the full model, and still see which one will be most profitable. But right here, they are quite consistent between the most accurate and the most benefit.
We evaluate the model based on two metrics. The first one is confusion metrics, including accuracy, recall, and precision. And in addition, he run the simulation to see which one is more profitable. So that is the profit or cost matrix. So that is the additional mile Anthony walk in my class. So in my class, I did not require students to do the simulation and the profit matrix, but
So because with me, because I also have background in the industry, and talk back about the modeling, financial modeling time when I do in the industry. So all the time we had to mostly run the simulation to see our business decision will make the money or not. And that time I remember that we run a tool, an add-in on Excel called Crystal Ball, provided by Oracle. And you know how much it cost? It's $1,000. For just a simulation tool add on into Excel. They're quite easy to use. But I mean, with the time for the calculation, our studio overperformed them. And they ship freely compared to $1,000 that I had to pay for. So
Good. What variable did you find had the most impact on your predictions?
yeah, so here we can use some actually for the prediction. Sometimes people not really so care about what variable can we have the highest impact into the decision, but they will take care of more about how they can be applied and make the higher accuracies. But anyway, the decision tree and the logistic method, they can really generate to interpret about the result. And for example, when we take a look into the decision tree, so the delinquent of the debt will be get the higher impact. The second thing can be see right here will be the debt over income of the customer. So with here we can see what kinds of determinant will be make a very high impact and make the highest effect into the decision.
Good.
Yeah. So it's really hard between what would be the most accurate model. Normally they hard to interpret, but they're very accurate in the prediction power. And for the traditional method, they're easy to interpret, but sometimes they're not so accurate.
Yeah.
So we have to use the different method to just benchmark for the model and to see and support for the decision making process.
Good. Thank you.
Yeah.
Thank you so much. Thank you for coming and for supporting Dr. Chen and Mr. Nguyen. So thank you.
Excellent.
And
Yeah, thank you.
you can ask next.
Oh, yeah, actually, yes,
Thank
please.
you.
Thank